build and measure a parallel circuit using the PhET app. First, let's turn on values and conventional current. Next, let's get our circuit elements. I will use the same values that I used in the analysis that you just watched. So I'll have a 12-volt battery, a 10-volt resistor. Now remember, when you build your circuit, you're going to use this resistor only because it has a higher resistance, which is what you need for yours lab. And I need a second resistor that's 40 ohms. There. Now we have our circuit elements. We can begin to hook them up. There are many ways to hook them up. I will use the same sort of battery on the left, resistors on the right, and make it look kind of like a ski lift. Now we need wires. I'm going to put a little extra wire on top of each one so that I'll be able, when I need to get my ammeter in, I'll have space where I can get the ammeter in. Notice as soon as we have a complete loop, current begins to flow. And now current flows in the second loop. You might notice that the current is flowing much faster in the 10 ohm than it is in the 40 ohm. This should make sense because both resistors have the same voltage, the battery voltage. So the one with the lower resistance has a higher current. Now we can measure our voltage by placing the two ends of the voltmeter across whatever we're trying to measure, in this case the battery, and we see the voltage is 12 volts. We can move along to the first resistor. And again, it's 12 volts. Move along to the third resistor, and it's still, you might notice, 12 volt reading. Why? Because we're connected by a wire. It doesn't, voltage on a wire doesn't change. So it's 12 volts over there as well. Indeed, all three circuit elements have the same voltage, the voltage of the battery. Now let's measure the current. To measure current, we must get the ammeter in the circuit so the current flows through the ammeter. To do that, we will remove one wire at a time and connect the ammeter. The total current out of the battery is 1.5 amps as we previously calculated. Now we'll put our circuit back together and move to measure the current through the first resistor. The current in that resistor is 1.2 amps. The current in the second resistor is 0.3, and indeed 0.3 plus 1.5 equals the 1.8 that came from the battery. We have successfully built and measured this parallel circuit.